So this is 6.4C elementary algebra, and what this lesson is we're just going to go over some of the problems in the problem set, because again this more on factoring patterns or special factoring patterns can be a little bit difficult, so I thought, well, we'll go over a few more of these. Alright, so first 22 is the idea of factoring trinomials. So let's jump to, let's do 20. Alright, so if you remember from the examples that we did, clear back, trying to get thumb back in my book, perfect square trinomials. We're trying to find out if this is, we know it's a trinomial because there's three terms, 1, 2, 3. But we need to find out if it's perfect. And you find out if it's perfect by, is there a number we can multiply by itself to give us that? Yes. Is there a number we can multiply to get that? Yes. If we put these two together and get 5xy, and then we double that, do we get that middle term? Yes. Okay, since all that is true, then it is a perfect square trinomial, and we can write our answer very quick and easily by just putting 5x here, putting a y there, and then just putting a plus sign there, because it's this sign here. If that were a minus sign, then it would be 5x minus y, and that's it. Okay, so 23 to 28 is your factoring, and then finding, or factoring the whole thing by first factoring out the greatest common factor. So let's look at 28. So let's see if we can factor something out. Is there something common to 12, 36, and 27? 3. And we do that. This is a 4. This is a 12. And this is a 3 times 9. Gives me 27. So I took a 3 out. Can I take any letters out? I've got an x there, an x there, and a y there, so can't factor any x's out because I don't have any in the third term, but I have 1 there, 2 there, and 3 there. So I can take out the one that occurs the least, and I'm left with that, and I'm left with 1y there, and over here I'm left with 2 of them. Okay, now I'm factoring this. And one of the things that I notice is it's a trinomial. 1, 2, 3 terms. Can I find a number that I multiply by itself to give me that? 2x. We'll do that. How about a number I can multiply together to get that? Okay. And if I multiply these together and double them, do I get this? Yes, I do. So because it does, it's a perfect square trinomial. So because of this minus sign, I put a minus there, and I bring that 3y down, and I square that, and I'm done. Okay, let's factor some binomials, and again, the key to this is practice, 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 and taking good notes. So 72, 50, oops, 50 a squared b minus 72b. Okay, what can I do with that? I can do absolutely nothing with it yet, but I have a b that's common to both of those. Also, I have a 2 that will go into that and a 2 that will go into that, so I'm going to take the 2b out, and that's going to leave me 25a squared minus 36. Okay, so I took a 2 away from the 72. I divided 2 into 72, got 36. Divided 2 into 15, got 25. This b and this b both came out, leaving me no b's. And let's see what we've got left. Is there a number multiplied together that will give me that? 5a. Is there a number multiplied together that will give me that? Yes. So now all I have to do is put a plus there and write it again and put a minus there, and I'm done, because this is the difference of two squares. If I square 5a, I get this. If I take square 6, I get that. So I get two squares, and the difference, I've got a minus. So that means I put a plus on one, a minus on the other, but the numbers are the exact same. Okay. So if you look at one like 79, there you've got the difference of two cubes. And that one is exactly the same as example number 9. Alright, so let's keep looking here. Probably one that'll give you a little bit of a struggle, and we'll go ahead and do that. I think it was number 100 if I remember right. Let's look and see if it was. Yeah. Okay, so what would happen if we change this 4x to the 6 to a 4x cubed and then squared that? Okay, so remember, we can take this, and if we break this up into it's still 3 times 2 is 6. We just split it up. And if we did the same thing like that, now what do we have? We have the difference between two squares. Okay? So the difference between two squares says we take this minus that, and we multiply that by the same thing, but we put a plus sign. Okay? Now what do we have? This is probably one of the hardest problems that you've encountered so far. Now we have bottom of page 411, we have the sum and difference of two cubes. So if you remember, the sum of two cubes was a cubed plus b cubed equals and the difference between two cubes looked like this. So we're going to use both of those because we have an a cubed plus b cubed over here. We've got a number cubed plus something else cubed here. And here we have an a minus b, here we have a minus here. So we're going to use both of those. So let's do this one first. It says we're going to take the first term minus the second. 4x, do this in blue, minus the second. Okay? Now we're going to ignore this. We don't look at that anymore. We're just going to follow this pattern here. And then it says we're going to take the first term and square it. Plus first times the second. 4x times 7y is 28. Then it says I'm going to square the second term. The second term is the 7. Okay, in fact it's a 7y. Okay, so the only thing I have to do is right here, I've got 4x squared. I'm going to rewrite that as 16x squared, because 4 squared is 16. Okay, so I just did this part here. Now I'm going to look at this one, and I'm going to use this example here because of the plus sign and the plus sign. Alright, we'll do it in white. So what does it say? First two add together. 4x plus 7y. Okay, so we're going to get rid of this. We don't care about that to get the rest of it. Alright, what does it say? We're going to take the first term and square it. So we're going to take 4x and square it. 4x squared is 16x squared, right? And the second part says we're going to put the two together. 4x in 4x, where are we? 4x and the 7y together, AB. Okay, put them together. We have to put a minus sign there. AB, 28, 4 times 7, xy. Next step says that we're going to add b squared, add the last term. The last term is a 7y, and we're going to square that, 49y. And don't forget to square the y. Alright, that is the entire answer. Whoa, I did it right the first time. These are hard. They can be very hard. Hopefully luckily that's number 100. So that's the last one of those kinds. So you can do that, or at least follow along. You should be okay with, well, golly, they start with about 95, 6, 7, 8, 9, and 100 all have the 6th power. But if you follow the guidelines that I gave, you shouldn't really have too much trouble with those. Well, too much trouble. It shouldn't kill you anyway. Alright, so that's it for 6.4C.